Good morning to one and all. I am Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I am going to explain about the digital modulation technique, which is about amplitude shift keying. First of all, we see why we need digital modulation. Digital modulation is required if the digital data has to be transmitted over a medium where it allows only the analog transmission. That is, in place of modem, it is a wired network. But for digital signals, that is zeros and ones, can be sent over using voltages. Wireless must be use analog sine waves, where this translation is performed by the digital modulation, where digital data is translated into an analog signal. And whereas we allow various shift keying techniques. First one is amplitude shift keying, frequency shift keying, and the phase shift keying. Here the representation of digital data. First we are sending the data to the modulator, where modulator modulates the received digital data, and it is via the communication link the data is being transmitted to the analog to digital converter, where here modulator converts digital signal into analog signal. That analog signal is given to the demodulator, where analog is converted to the digital signal there, then it is given to the receiver. The types of analog to digital conversion, that is we have different conversions, various shift keying, amplitude shift keying, frequency shift keying, phase shift keying, and quadrature amplitude shift keying. Here the carrier signal or carrier frequency plays a main role, where a high frequency signal which acts as a basis for the information signal. Those digital information modulates the carrier signal by modifying one or more of its characteristics, that is amplitude, frequency or phase. This kind of modification is called as a modulation or shift keying, and the information signal is called as the modulated signal. This is the waveform where the digital data we usually represent it as 1 and 0. 1 is nothing but the data will be the kit will be on, and if it is 0 it will be off. But the carrier signal will be of same as that of the carrier signal is same for both zeros and ones, but while it is while it is getting modulated, where for one the signal will be in the signal will give its amplitude and frequency, but when it is 0 the data will be in off condition. Bit rate, here bit rate is nothing but the number of bits per second the data is being transmitted, and baud rate is about the number of signals in which the data is transmitted per unit second is called as a baud rate. We'll see here about amplitude shift keying. In ASK, the amplitude of the carrier is varied to represent binary 1 and 0. Here, the both the frequency and the phase remains constants, only the amplitude changes. The peak amplitude of the signal during each bit duration is constant, and its value depends on the bit of zeros and ones. Yes, when we consider it in optical, where we'll consider as if light on, it is 1. If 0, the light is in off. This amplitude shift keying is also called as a on-off shift keying, as this light switch is on off, that where we called it as a amplitude shift keying is called as a on-off shift keying, and it is also called as a binary amplitude shift keying. Here this is the generator of amplitude shift keying. Here first we are giving the carrier wave, then the binary data sequence, with this switch acts as on off here, and finally it gives us a ASK waveform. Amplitude shift keying generator. First, the signal generator produces a high frequency sinusoidal waveform in the digitalized form. Then the switch provides here, where we have seen that a switch there in the generator block diagram, in that it opens and closes. When the digital data of level high, it is 1. Then the switch gets closed, it goes 0. As against in case of low level, the switch gets closed. This is the reason why the signal appears at the output in case of a high level. After this, the pulse reshaping is done by the band limiting filter according to the amplitude and the phase characteristics of the filter. Then the detection or demodulator is a process of recovering original message signal from the modulated waveform, where detection involves two processes. One is coherent detection and another one is non-coherent detection. In case of coherent detection, that the carrier at the receiver must be in synchronization with the carrier at the transmitter for actual detection. The demodulation circuitry consists of a product modulator along with an integrator and a decision making device. The input to the product modulator is a modulated waveform along with the sinusoidal carrier. The combination of two is then fed to the integrator and it operates successfully in order to get the bit interval, after which it also executes the filtration of the signal. When the signal exceeds the threshold value, that is then a bit 1 is provided by the decision device as its output. However, when the signal decreases, then the threshold bit will be of 0. If it is high, the threshold bit is 1. If it is low, the threshold bit is 0. This is the detector. Here, as I said, here integrator and decision device is used in order to control the values. This is the mathematical representation of the ASK modulated signal. If it is 1, where it is on. If it is 0, the signal goes completely low and we'll see here an off. Pulse shaping can be employed to remove here the spectral spreading. Non-coherent receiver. In coherent receiver we have used integrator and the decision making device, but in non-coherent receiver we are using only the filter and the rectifier circuit. Instead of integrator we are using here envelope detector, where it consists of a rectifier circuit and a low pass filter. This is the power spectral density of the amplitude shift keying, where the signal goes high. The advantages of amplitude shift keying is shown here. It has a simpler receiver design, that is we call it as on off shift keying, where it is used to relay Morse codes over radio frequencies. Likewise, this digital data can be transmitted over optical fiber using ASK modulation. The disadvantages is it offers low power efficiency and also poor bandwidth efficiency. These data techniques are not suitable for hybrid data transmission. Applications are this we have seen on off shift keying. It is mainly used in optical fiber in order to transmit the data from one place to another. The technique was widely used in traditional telephone modems, where where in modems also it also transfers the data. Thank you.